9-3, rotations. Okay, what's a layman's term for a rotation? What did I call it before? A turn, right? Like you turn a doorknob, a rotation, a turn. So we're going to be talking about turns or rotations today. Rotations preserve distance, angle measure. Oh, I already wrote measures there. That's just angle. Distance, angle measures, and orientation. Okay, meaning they're going to be the same size and shape, right? That's what distance and angle measure did. And then remember, orientation said if you're naming it clockwise, you're going to keep naming it clockwise if it has the same orientation. So rotations have the same orientation. So if I name my first figure clockwise, then I'm going to name my next figure clockwise. If I name the first one counterclockwise, then I'm going to name the next one counterclockwise. So it does not flip at all, right? Flips are the ones that have opposite orientation. These have same orientation, okay? Okay, so let's take a look at this. This is just kind of the general setup of what a rotation will look like. You're always going to have what's called an angle of rotation, and you're going to use this little guy to figure out that angle. And it's always going to be the same angle, right? If it preserves distance, angle measure, and orientation, it has to keep the same angle the whole way through, or you're going to have a totally different figure by the time you're done, okay? So the angle of rotation, that'll be this little angle right here. And basically what you do is if I start with triangle, what do we want to call this? VUW, we'll say, okay? If I rotate it, my V has to become my V prime, my W becomes my W prime, my U becomes my U prime, right? So if I connect from my point of rotation, this is called your point of rotation. Okay, that's the point we are rotating around. If I connect a line to V and V prime, I get my angle of rotation. So you guys are going to be drawing that line in. You're going to connect your point of rotation to the point you're trying to rotate, then you're going to measure your angle, and you're going to mark your new point, okay? And that will make more sense once I lay it all out for you, but just so you're clear on that. Okay, like I said, this segment here and this segment here, they're going to be the same length. Okay, that's what this is saying. These two segments will be equal in length. We always rotate. One of you asked me this in class the other day. What direction do we always rotate? Counterclockwise. Okay, so we are always going to rotate counterclockwise. Who asked me that? I don't even remember. Copper. Good job, Copper. We're always going to rotate counterclockwise on these. And then we will write the X degree rotation, so however far we're rotating of the triangle about point Q, like this. Here's your notation or your rule. Remember, we've been kind of calling this the rule. We're going to say it's a lowercase r, which matters. Why can't we call it a capital R? That's a reflection, right? We did those already. Now this is a lowercase r for rotation, okay? And then what you do is you rotate it X degrees. So that's going to be your subscript, X degrees. And then you do comma, and then it's the point that you're rotating around. So we said we're rotating about point Q. So we're going to put that point Q down here. Okay. And then you just name what you're rotating. Triangle, if I say UV, I guess I said UW. UWV is going to map onto triangle U prime, W prime, V prime. Okay, so when we write the rule, this is your angle of rotation. And Q is your point of rotation. Okay. Okay, so if you've been working on your iPad, move to your paper, and we are going to do a rotation. Out of these by my last class, I think. I didn't really think about that. You need One of these, and maybe another pencil. I do. They're gonna feel hard at first just because it feels like you're doing a lot of things, but really you're doing the same thing 3 times. Okay, let's switch over and take a look here. Tell me to slow down if I go too fast, okay? First of all, can anyone tell me what this is telling us to do right now?
What is the rotation of triangle LO to 100 degrees?
We're going to rotate 100 degrees around point C, triangle LOB. Okay, so we have this triangle, we have this point. You need to rotate 100 degrees. 100 degrees in what direction? Counterclockwise. Okay, so here's where we're going to start. I always pick the point that's furthest counterclockwise because then there's less overlap at the beginning. So which point is furthest counterclockwise right now on my triangle? What? I would say B. If you're thinking of it as a figure, right? Furthest counterclockwise, if we're going in a rotation here, because eventually our figure is going to end up this way, right? So furthest counterclockwise, I would say is point B. So here's what you're going to do. You're going to take your straight edge, your protractor, and you're going to draw that line in that I was showing you that connects B to C. Okay, so you should have segment BC right now. Now remember, our angle of rotation comes off of the point of rotation. So basically what we're doing here is we're trying to make an angle right here, counterclockwise. That's 100 degrees. Do you remember how to measure an angle? Hopefully, it's been a little while. Take your protractor, okay? Yours might look a little different than mine, but it's gonna have the same basic idea, right? You have your point that is supposed to be your point of rotation. That's going to go right here. So I'm going to line that up with C. Now, notice I'm going this way. I'm going counterclockwise. Don't set it up this way because that's going clockwise. You need to set it up this way. So notice, here's my point. You want your line at 0. Okay, now here's my question. On my protractor, yours might be different. It's probably not different, but it might be. So that's why I'm asking on my protractor. Which set of numbers am I using? Is it going to be the outside or the inside set of numbers? The inside. We have to start at 0, right? So if I start at 0, 10, 20, 30, 40, all the way around to 100, all you're going to do is put a little mark at 100. Okay, so right now you should have something like this on your paper. Can I move on? Okay, what you're gonna do is you're gonna create that angle. So we're gonna connect C to that little mark. So take your straight edge and draw that in. You're almost done, okay? Well, you're almost done with the first round of it. Now what you need to do is you have to make sure, remember I said, was it VW had to be the same length as VW prime? You need those to be the same length. That's where your compass is going to come in handy, okay? You're going to measure it. So put the point at C and open to B. That measurement, I'm just going to rotate my compass around and put a little mark. And now what point do you suppose this is? B prime. So this is a 100-degree angle. And that is B prime. Let me show you one more time, okay? So you measured B to C. You rotated it around to that line that you made, and you marked your B prime. West.
Is it always 100 degrees?
No, it'll change every time. So you just have to pay attention to what this says.
Oh. Okay.
Right? Yeah.
Was the arc supposed to line up with
Sorry. Show me on your paper.
So the 100 degrees was right there, is it okay if I just?
Yes, because this is just you made the angle 100 degrees, right?
Oh, okay.
So this is a 100 degree angle, and now, I know, that was a fluke.
Okay, where'd you get C from?
My little part, where did I get C?
Like, yeah, what's that
C was
just
given.
random? It's just.
Yeah, C will, your point of rotation will be given to you. Okay, so that's what you're doing. You just did the whole process. You just need to do it 3 times. Okay, so I'm gonna do it second time now. You ready?
Yeah.
Okay, this time, I'm going to use a different color so you can see the difference. So now I'm gonna do point L. Okay, I'm gonna rotate L. So first thing you do is you draw a line that connects L to C. Okay, do you remember the next thing you do? Now you have to measure the 100 degrees. So you're gonna set up your protractor. Is it gonna look like this? Or like this? Which way is gonna send me counterclockwise?
The other way.
The first way, right? We wanna go from L, we wanna come this way. So I'm gonna line that up. Okay, it looks like this. Here's a little secret for you. If you're always rotating counterclockwise, you will always use the same set of numbers on your protractor. So figure out on your protractor, is it always the bottom set of numbers? Mine is always the inside set. You will always use that same set because that's what counterclockwise will be, right? Okay, so 100 degrees using that bottom set of numbers. I put a little mark right here at 100. And then I'm gonna connect C to that little mark. Do you remember what you do next?
Rotate, you measure this, the length of L and rotate it.
Measure LC. Okay, so here's LC. Measure that with your compass. And mark it on, mine is my blue line, yours is whatever you're working with. Okay, so put my little mark there. And now that point is what point? L prime.
Wait, when you're making the mark, you measure from C or from?
Always from C. Everything comes from C. Like you're always working from your angle of rotation. So for drawing your lines in, for measuring your angles, for measuring how far the point is away, everything's from C.
How did you get that second line?
I measured 100 degrees. Right, so I put a little mark at 100, and then I connected that to C. Okay, so now you have 2 points. Now your last step is do the third one. And this one I'm just gonna do in pencil. So I'm gonna draw the line in from O to C. You guys can do these all in the same color. I'm just trying to make it more visually acceptable to you. Okay, so draw that OC line in. And now we're gonna go underneath because we're going counterclockwise. 100 degrees is right here. Put a little mark at 100 degrees. And then draw that line in from C to that point. Okay, what am I measuring right now? What's my next step? CO, right? I measured from C to O, like this, and then I mark it on that line that I just drew. So keep your point at C, put a little mark here. That is now my O prime. Do you see your triangle? Connect your 3 points, B prime, L prime, and O prime. Okay, and we said a rotation preserves distance, angle measure, and orientation. So whatever you started as, this triangle right here, should look just like this triangle you just made, right? If it doesn't, you did something wrong. Now if it's slightly off because your protractor compass isn't in perfect tip-top shape, that's okay. If it's like a totally different shape, then you have a problem, okay? So that is a rotation of 100 degrees around point C. Any questions on that? Okay, I'll do another one of those at the end. I'm going to go back to the notes now, but I will do another one if you want to see another one in a little bit. I just want to make sure we get through all the other things we want to get through. Okay. This, I don't do a ton with this. I don't make you memorize what these will do. But I'm going to show you what a rotation of 90 degrees, what a rotation of 180, and what a rotation of 270 will do in the coordinate plane for you. Because it just gives you a good feel for like what a rotation actually does. So rules for rotation in the coordinate plane. If you rotate 90 degrees, whatever point you started with, X and Y, okay, what happens is you end up taking the opposite of your Y value, and that becomes your X value. And then your X value becomes your Y value. Okay, and I'll show you all of this in just a minute, but I'm going to give you all the rules first. So that's the first one. If it's a rotation of 180, your X and Y that you had become the opposite of X and the opposite of Y. Now that doesn't mean it's a negative. If it started as a negative, now it's going to be positive, right? It's just the opposite of what it was, okay? And then the third one, if you rotate 270 degrees, your Y value is now your X value. And your X value, we take the opposite of it, and that becomes your new Y value. Okay, so let me show you what I mean. Let's say you start with the point 4, 2. 1, 2, 3, 4, 1, 2. Okay, we're going to call that G. Okay, so here's the deal. G right now is the point 4, 2. Okay. If I want to rotate G 90 degrees, it now will become the opposite of my Y value. So what number is that going to be? -2, followed by my X value, which is 4. So -2, 1, 2, 3, 4 would end up right there. What happened was we just rotated 90 degrees around the origin. So now this is, if I were to connect this, right, that's a 90-degree angle. I rotated it 90 degrees. Does that make sense? Okay. If I want to rotate G 180 degrees, I just take the opposite of both my points, or both my coordinates. So 4 is now going to be a -4, and 2 is now going to be a -2. So -4, -2 is going to land me right there. Now notice this, 180 degrees, that makes a straight line, right? So this is another 90. 90 and 90 is 180. Okay. All right, last one. If I go 270 degrees, I take my original point, 4, 2. Now it's going to be my Y value, which is what? 2, followed by the opposite of my X value, -4. So 2, -4 is right here. And again, another 90-degree angle set up. So from G, I went 90, 180, 270, and that's where I ended up. Okay. Like I said, I don't ever make you memorize those and be able to put them down, but it is helpful when you're trying to do rotations. If you understand what's happening to them, it just makes it a little easier to find the points that you're trying to get to. You don't need to memorize them for me, okay? But I do want you just to see how they work. Okay, so let me show you on this then how we do a rotation like that. If we have triangle ABC, so here's your points. A is at 1, 1. B is at 4, 2. 1, 2, 3, 4, 1, 2. And C is at 0, 4. 1, 2, 3, 4. Okay, now if you're doing it on paper or even on your iPad, if you rotate your coordinate plane, you're not gonna see this on mine, but if you just turn your iPad, so I had it like this, right? And now I turn it like that. If you can do that without making your screen change places, you should see exactly where your new figure should be, right? But again, if that doesn't happen, it's okay. We know how to do it this way, right? Rotating at 90 degrees is going to be the opposite of my y followed by my x. So take a look at this. A prime, opposite of y would be -1. My x is 1, right? My b prime, opposite of y is a -2. My x was 4. My c prime, opposite of y is a -4, and my x is 0. Okay, so if I plot those points, it should look like a rotation of 90 degrees. Plot them. -1, 1 is a prime. -2, 1, 2, 3, 4 is b prime. And -4, 1, 2, 3, 4, 0 is c prime. If you rotated your paper or iPad before, that's what you should have been seeing, right? So that's a rotation of 90 degrees. In other words, this is a 90-degree angle, and this is a 90-degree angle, and this is a 90-degree angle, okay? You don't need to draw those lines in, but I just want you to see that's where your angle of rotation is happening. We're rotating around the origin, right? This would be our point of rotation, 90 degrees. Any questions on that? Okay, then last thing. This one is tempting.
I have a question.
Yeah, what's up?
On the, so do we have to have these things memorized?
No, I won't ever make you memorize them. So just have them in front of you in the notes while you're working. Really, you will be able to see the ones that I give. Like I don't put any of those rotations of 90, 180, 270 on your quizzes or tests where you have to come up with the new point for me.
Oh, okay.
Yeah, I'm not going to make you memorize all these X's and Y's and where they go. But yeah, you will do some of it in the homework, and we will do more of it. It's just not going to be like a big quiz test push. So don't spend time memorizing. I mean, if you want to, go right ahead, but you don't need to for me. Okay, last thing, and this one gets done wrong. This one is on the quiz or test, and it gets done wrong a lot because people try to measure it with a protractor. You cannot measure this with a protractor, okay? It says rotating around point X, so this is your point of rotation. Point X is your point of rotation. What is the angle of rotation from B to F in the regular hexagon? Okay, it's a regular hexagon. I'm starting at B, and I'm going to F. What direction am I going? Counterclockwise. So I'm going like this, right? From here to there. Don't go this way. That would be clockwise, okay? Okay. Anyone have any thoughts on how we could figure this out? Whitney.
Connect B to X.
Okay, connect this line. Yeah, Bella.
Would it? Never mind, actually. That won't work.
So like if we, I forgot what lesson it was, but if we, wait, so this is 6 sides, so if we do 6 minus 2 times 180 and we find that, then we can add 3, no. Wait, so we,
Okay, so n minus 2 times 180 found you these angles, right?
yeah,
We want the angle of rotation. So we're going to connect the F to X. How would I find this angle? Can anyone tell me this angle? 360, right? And it's a regular hexagon. Divide by 6. So you're going to take 360 and divide by how many angles you would have, right? This would be 6 total central angles. Okay, so 360 divided by 6 is 60. That means every one of these central angles is 60 degrees. So what is the angle of rotation from B to F? 120. There's 2 of them there, right, to make that angle. So 60 times 2 is 120 degrees. Okay, so just remember on these problems, you are not using a protractor. It's got to come from 360. Don't measure it. If you try to measure it with your protractor, you're going to get the wrong answer because I won't draw it perfectly to scale. Okay, so 360 divided by however many angles you have, and then multiply by how many angles you're trying to move through for that. Questions?